Okay, as we learned in the last chapter, this is the first section in chapter 1. We're just doing a couple sections in this chapter. But the first section is on electromagnetism. So we know that electric current and magnetism are related to each other. They kind of go hand in hand. So an electric field has a magnetic field, and a magnetic field has an electric field. Like they kind of work hand in hand. And because of that, we have these things called electromagnets. Because an electric current produces a magnetic field, there's a relationship between these two, and it's called electromagnetism. And you can see here, and I tried showing you this at our Zoom meeting too, when we were doing this. It's probably hard to see. But when no current is running through this, because it's unattached right here, you can see that the circuit has been broken because something's been unattached from one of the places where you attach your batteries there. There is no, like the compasses are all facing north. There's no problem. So they face magnetic north. Whereas here, if we attach it back on there, and we have a nice current going through here, we configured the circuit, you can see that the dials here on your compasses are all like messed up because that magnetic field going through there basically causes, because of the electric current, causes those to kind of go all haywire because the magnetic field is affecting the compass there. So these two have a very direct relationship, and because of that we have this stuff called electromagnetism. Okay, so the first part of an electromagnet is a solenoid. We'll talk about different parts, but in order to really understand what a solenoid is, we need to recognize that a magnetic field produces current by three characteristics. So there's three characteristics of that current produced by a magnetic field around that current going through the wire. The field can be turned on and off. So if you don't have a current running through the wire, you don't have a magnetic field around it. That kind of shows here. If I have a current going through here, I have a magnetic field that's going around this particular wire. If I reverse this as well, which is the second part, the field can have its direction reversed. If somehow the current comes from this way and heads this way, then the magnetic field also gets reversed. So depending on which way the current is going also determines the direction of the magnetic field. So again, if we turn on and off, the direction can be reversed, and its strength can be changed. So again, if we basically bunch up some of this wire, if I bunch up the wire here, what can happen is I can have a stronger magnetic field because I have more wire kind of in a certain area. So all of those things have something to do with this electromagnet. And then the solenoid, which is the thing we're going to talk about in the next one, is kind of the basis for all of this. And this is kind of showing you what a solenoid is all about. There is a current running through here and is producing a magnetic field, and we're going to talk about how that is affected by certain things. Okay, so as I was saying on the last one, solenoids, this is kind of the basis of your electromagnet because it's kind of the magnetic part of it. So we have the current going through here, and we have some wire around here as well. And so we have to have a magnetic material in the middle here, and then we have this wire twist around the magnetic material. And the more twists you have around it, or the more twisted it becomes, that wire, the stronger the magnetic field will become. So the number of loops there is definitely going to affect how strong the magnetic field is in the electric field as well. So we have a solenoid. It's basically a coil of wire with a current. It is called a solenoid. The two ends of the solenoid act like magnetic poles, so they become very magnetized. And the more loops it has, the stronger the magnetic field. So the more loops you put on there carrying electricity through, the stronger the magnetic field becomes. You can actually make an electromagnet using a battery, a screwdriver, and some wires. If you were able to attach your wires to the two electrodes at either end of the battery, so you've got a current going through it, and you wrap it around the head of the shaft of the screwdriver many times, you can create a magnet. You can magnetize the screwdriver basically by turning on that current. And so that ferromagnetic material would be the metal in there, which becomes a solenoid because it has a bunch of wire wrapped around it, and as soon as you put a current through it, you got yourself an electromagnet. Okay, so as I was saying, an electromagnet basically is a solenoid with a ferromagnetic core, and electromagnet is a strong magnet that can be turned on and off. So if we don't have a current going through the situation, like if we don't have a current basically around that magnetic material, you're not going to have the electromagnet. So if you can turn the current off by basically shutting off the wire or releasing the switch or unplugging it or something like that, you don't have current going through it, you're not going to have an electromagnet. So this is an example of an open versus closed circuit in a doorbell, which is an electromagnet, type of electromagnet. So the closed circuit, everything's going through just fine. And so we've got we've got a current going through here. We've got a metal bar, which is a metal can be magnetized here. And we're putting the coils around it, creating an electromagnet, which causes the bell to ring. If we turn that off for some reason, we basically shut the switch off or something like that, we are no longer going to have that circuit anymore. So once we turn it on, the electromagnet, we've got something to work, we can turn it off by doing the exact opposite. Okay, so here is your a really good example, I think, of an electromagnet. If you've ever been to a junkyard or you've seen one of those cranes that kind of lifts heavy materials around, it's a really good example of an electromagnet that can be turned on and off. The advantage of something like this is if I want to pick up something magnetic, I can turn it on, I can pick it up, and then bring it to another spot. If I want to put it down, I just turn the magnet off, and the material basically falls from the magnet. So it's a pretty easy way of moving heavy materials. Like if you've ever been to like a car junkyard or something, they want to move a car around, they'll use something like this. But the most common places you'll find electromagnets, audio tapes, recorded your voice on something like a tape recorder, videotapes, computer hard drives, doorbells, credit cards. Credit cards have electromagnets in them. They're useful for lifting heavy objects, like I said, because they can be turned on and off. So the cool thing about electromagnets is basically a magnet that can be turned on and off when an electric current goes through it versus isn't going through it. This is the end of our first section in Chapter 3, which is on electromagnets. There will be homework posted for this on Blackboard, as well as you should find it in your packet if you got one of the packets at Pickup. This should also be in there as well. There's several ways you can do this. You can do it online, you can print it off, you can use the packet, you can take pictures, you can hand it in to me, you can print them off and then hand them in at the next hand-in date. There's lots of different ways you can, but any of those are acceptable ways, and they're due in the middle of April. Enjoy!